Good morning, students. Today we are going to discuss some basics from Unit 3 of Distributed Systems. We discuss about distributed mutex and deadlock. In that, we are discussing about distributed mutual exclusion algorithms. Let's go deeper into the content. Mutual exclusion. What do you mean by mutual exclusion? It's nothing but it's a concurrency control property which is introduced to prevent race conditions. It is the requirement that a process cannot access the shared resource while another concurrent process is currently present or executing the same resource. So even when we discuss in operating system, we know what is critical section, what is mutual exclusion. So similar concept. So mutual exclusion in a distributed system, it states that only one process is allowed to execute the critical section at any given time. Okay, so maybe shared variable or shared resources will be there. That particular section is called as critical section. In that, any one of the process can able to enter into it at a time. No two processes are able to enter the critical section at the same period. Okay, so that is called mutual exclusion. Definitely, with the help of message passing only, we can able to implement this distributed mutual exclusion. The decision as to which process is allowed to access to the critical section next is arrived at by message passing only, in which each process learns about the state of all other processes in some consistent way. Okay, so we have different variety of approaches to decide which process going to enter into the critical section. And such approaches are token-based approach, non-token-based approach, and quorum-based approach. We'll see one by one. So let's start with token-based approach. So definitely from the name itself, a unique token is shared among all the sites or all the processes. If a site possesses the unique token, it is allowed to enter into its critical section. Okay, this approach uses sequence number to order request for the critical section. Each request for critical section contains a sequence number. This sequence number is used to distinguish old and current requests. Like we will suppose first time I'm requesting me, the number will be 1. Second, 2, 3, something like that. The numbers will be used based on the number in the ascending order. We can schedule or we can allot the site to enter into the critical section. Okay. So definitely, since whoever having the token, they can be able to enter into the critical section. So automatically, we are ensuring that there is a mutual exclusion. Best example is Suzuki-Kazami broadcast algorithm. So that algorithm actually uses this token-based approach. Next one is non-token-based approach. So here, a site communicates with other sites in order to determine which site should execute critical section next. This requires exchange of 2 or more successive round of messages among sites. So with the help of message passing only, we are actually allowing any site to enter into the critical section. This approach uses timestamps instead of sequence number to order request for the critical section. Whenever a site make request for critical section, it gets a timestamp. Timestamp is also used to resolve any conflict between critical section requests. Like suppose 2 or 3 sites are at a time or somewhat in minor differences, they are planning to enter into the critical section. We can check the timestamp with the accurate time. We can schedule depending on the value of the timestamp. We can schedule those sites in an order. And all algorithm which follows non-token based approach maintain a logical clock. Logical clock gets updated according to Lamport scheme. We studied this Lamport scheme in second unit also. The best example here is Lamport algorithm as well as Raikant-Agrabala algorithm. Okay, so it's all about non-token based approach. The next one is quorum based approach. So quorum based approach here, instead of requesting permission to execute the critical section from all other sites, each site requires only a subset of sites which is called a quorum. Any two subsets of sites or quorum contains a common site. This common site is responsible to ensure mutual exclusion. So the best example is McKeever algorithm. Okay. So then apart from that, whenever we are creating the algorithm, definitely we need to focus on 3 important properties. One is a safety property, liveness property, and fairness property. So for the successful mutual exclusion algorithm, we need to ensure that these 3 properties are satisfied. So we'll see one by one what are these properties. Safety property. Safety property states that at any instant, only one process can execute the critical section. This is an essential property of mutual exclusion algorithm. Suppose we are ensuring means the algorithm is safe. Liveness property. This property states that the absence of deadlock and starvation, two or more sites should not endlessly wait for messages that will never arrive. In addition, a site must not wait indefinitely to execute the critical section, while other sites are repeatedly executing the critical section. That is, every requesting site should get an opportunity to execute the critical section in finite amount of time. Okay. So that is liveness property. Fairness property. Fairness in the context of mutual exclusion means each process gets fair chance to execute the critical section. They all treated equally. In mutual exclusion algorithm, the fairness property generally means that the critical section execution requests are executed in order of their arrival in the system. Okay. Then that's all about basics about distributed mutual exclusion algorithm. Thank you for listening.